अस्सलाम वालेकुम स्टूडेंट्स। आज जो हम टॉपिक करने जा रहे हैं वो है स्लोप एंड डिफ्लेक्शन मेथड। और इस मेथड को हम अप्लाई करेंगे फॉर फ्रेम स्ट्रक्चर्स। और इन टर्म्स ऑफ फ्रेम्स वी विल गोइंग टू एनालाइज द नॉन स्वे फ्रेम्स विद support settlement and without support settlements. In the last lectures, I have covered about the slope and deflection method for beam structures and with both support settlement and without settlements. Now, today I am going to cover the first part of the frame structures. In terms of frames, we will have three types of structures. First one with the sway frames, then we have non-way sway frames, then we have inclined frames. And today I'm going to discuss the first part of the frames, which is non-sway frames. And in non-sway frames, we have two types of conditions: one with the support settlement and other with the without support settlement. Well, as far as the non-sway frames are concerned, or the frames without sideway sways, in these types of frames, we usually neglect the axial deformations. Why? Because they are usually very small as compared to bending deflections or as compared to shear or bending moment in the beams. So that's why we usually in types of frames we usually neglect the axial deformation in the members. And axial deformation means the force which is acting or which is causing the deformation along the length of the member. If it is a horizontal member, then axial deformation will be in the horizontal direction. If it is a vertical member like A to D, then axial deformation will be in the direction of A to D members, which is in the form of vertical directions. So in case of frames, we usually elect these types of axial deformations. And similarly, in these types of frames, what you are going to consider is, and the different types of sports that we have to consider. As I already told you in the lectures of beam structures, that the sports which are fixed in nature have both have neither translation movement, neither rotation, that there is be no value of deflection at the point D at the fixed spot, which is point A and the B. So point A and B can neither rotate nor they can translate. It means that there will be no value of theta A and there will be no value of delta A if they are fixed spot. Similarly, if we see the point C or the spot C, which is pin in the nature, so the pin can rotate, right? The member can rotate in clockwise or anti-clockwise rotation, but member cannot move in the translation movement, and member cannot rotate in the horizontal movement. So that's why there will be value of theta. There will value of theta c, but there will be no value of delta c, and there is no deflection at the pin spot. Same is the case with the roller spot. Now, considering the joint D, which is basically the interjunction point of frame, more than two members or more than two members of the frame, where the interjection point it is free to rotate. It can rotate and it can deflect in any direction, whether it can deflect downward or it can deflect in the rightward direction towards point E. Similarly, it can rotate in the along the member A to D, and it can rotate along the member D to E, or it can rotate along the member C to D. So the intersection points are free to rotate and they are free to deflect in any directions. And the value of the direction or the value of rotation will depend on the loading conditions. And similarly, if we consider the joint E, the joint E in this type of frame can rotate, that it can cause theta E and theta E along the members E to D or along the member E to P. But it cannot move or it cannot deflect along the member D, E, and BE, because its rotation or its translational movement is prevented by the pin spot at point C. So that's why the such type of frame, the E movement, we do not have any deflection at the point E because it is a frame without side sway. And similarly, if we remove this support member, or if we remove this member C to D, and we remove the pin support, our member will become a simple three members frame, A, D, E, B. Now, in this type of frame, again there will be no translational movement, and there will be no rotation at point support A and B, and there will be rotation. There will be deflection and rotation at point D and point E at both points, because now there will be no support which is preventing the lateral movement of the frame. But in the case, but in the vertical direction, the direction or rotation of the member is prevented with the supports A to B. So therefore, we can say that joint D and E cannot translate in the vertical direction, but they can rotate and they can deflect in the horizontal directions. And the lateral displacement of such type of building frames are known as frames with side sway. So those type of frame which can rotate or deflect in any direction, they are called as sidesway frames. And the frames in which the rotation or deflection is restricted in both directions, that in x-axis and in y-axis, are called as non-sway frames. And but how we came to know that whether our frame is a sidesway frame or it is a non-sway frame? We check this type or this swayness of the frame, or the degree of the swayness of the frame, with the help of the degree of the freedom. And the equation for the sway degree of freedom is 2 times of 2j minus 2 times of f plus h plus r plus m, where j is the number of the joints in the frame, f is the number of the fixed supports, h is the number of the hinge supports, and hinge supports includes both pin support or in case of roller supports, and r is the number of the roller supports, and m is the number of inextensible members. Inextensible members are those members which cannot change its length upon the loading. And when the loading is applied, their length after loading or before loading, the length of the members remains same. And such type of members are called as inextensible members. Full- Let's apply this equation to the frame which we are already discussing. Suppose we have this type of frame. In this type of frame, we will have a number of joints is 1. One is at point C, 2 at point D, 3 at point A, similarly 4 at point E, and 5th at point B. So we will have five number of joints. And the number of fixed ports we have is two. One is point A and other is at point B. So we have two fixed ports. And we will have going to have a one hinge sport, and hinge sport is at point C. As there is no roller sport in the frame, so its value will be equal to 0. And m is the number of members, and we have a four number of members. One is B to E, second is E to D, third is C to D, and fourth is A to D. So we have total of four members. If we plug these values into the sway degree of the freedom, we came to know that the stat of side sway degree of freedom came out to be 0, and this value of 0 indicates that the member is non-sway in nature. If you got any positive value of the side sway frames, it means the frame is sway in the nature. The frame can rotate in the horizontal direction or in the vertical directions. Similarly, if we get its value as a negative value, that it means that the frame is unstable in that nature. Similarly, if we apply the same example on the frames with the side sway frame, in which we have removed the spin supports at point C. Now, the number of joints we are left with is the four. One is at the joint A, joint B, joint E, and joint D. And again, we have a two fixed supports at point A and B, and there is a no hinge support in this case because we have removed that support. And there is no roller support, and the number of members reduces to 3. And if we apply this equation and plug in these values into the side sway degree of the freedom, we came to know that its value comes out to be 1. So it indicates that the member can move or sway in the one direction, and the one direction will be the dependent on the loading of the structure. If the horizontal loading is dominant, it will move in the horizontal direction. If loading is dominant, it will move in the vertical direction. And the second thing that is depends on the number of the sports. If we have restraint or the sport in the vertical directions, the member will not be able to move in the vertical direction because there is a fixed sport at point A which is preventing its movement. So due to fixed sport at A, member cannot move neither from downward or neither from upward from the point A because it is fixed at the point A. But it can move in the horizontal direction if the loading is applied in the x-axis or in the horizontal direction. The member can move from point D to D dash, causing the delta or the deflection on the members delta equal to delta, and its value is calculated later on with the help of the slope and deflection equations. And if this value of deflection will remain as the same at point D and point E of the frame, despite that there is only a single horizontal loading in the structure. If there is more than one loading in the structure, then its value might be different a little bit. But for the frames which are purely symmetric in nature, symmetric in nature means they are symmetrical in terms of the loading, that the loading is applied and the structure is totally symmetric about its axis of the symmetry. That if we have only single point load at center of the span, then it will be considered a symmetric frame. If we have a horizontal mob load, then it should be applied on the both directions in the frame, then it will be symmetric in their nature. So the for frames which are symmetric in the loading, they will be considered as no non-sidesway frames. So there will be no sidesway frame in such types of frames. And secondly, these types of frames are considered as non-sidesway frames when it have equal length of the members. For example, if we have a same length of member A to D and B to E, the member will be considered as non-sway frames. But if we have a same loading but there is a different length of the members of a or length of the two members in any direction, then there will be a sway in the frames due to non-symmetry in the members dimensions or the member length. So in such type of frame there will be side sway frames. For the frames to occur a non-side sway frame, so there are two conditions. One, the frame should be symmetric in terms of the loading, and second is frame should be symmetric in terms of dimension of the frame. And if there is such condition occur, then even there is no support or strain in the horizontal directions, the frame, such type of frame will be considered as non-sway frames, because in such type of frame the deflection will be totally in opposite direction and they cancel out the effect of each other, ultimately restrict the movement and rotation of such type of frames. Now coming to the applications of or the solution part of the frames in which the loading is applied with the help of slope and deflection equations. Consider this example 1, in which we have four members. First member is A to C, second is C to D, third is B to D, and fourth is D to E. And we are required to determine the member end movements and the member reactions by slope and deflections method. And as you already know that if you know the member end movements and you can calculate the reactions, then afterward you can easily draw the shear force diagram and bending moment diagrams. As we have a structure in which we have a vertical loading of 2 kip per foot in the span C to D and D to E, while we have a horizontal loading in the members A to C of 40 kips, which is indirectly at the mid of the span or mid of the span A to C, which is about 10 feet from each side. And the length of the member C to D is 30 feet and the D to E is again 30 feet. Value of inertia varies for each members from 800 to 1600. For vertical members, it is 800 inch 4. For vertical member or horizontal members, it is 1600 inch 4. And the value of elasticity is given as 29,000 KSI. As we have seen in the previous example, for the frames in which we have a hinge support at either end of the frame, such type of frame is considered as non-sway frames. So this particular example is basically pertains to frames with no side sway frames or the non-sway frames, and there is no settlement is given in terms of the support at in the data. So it will be considered example of non-sway frames without support settlement, as there is a no support settlement neither at point A or at B or at point E. For solving this part, we will follow the same steps that we have followed for the beam structures. As we see that the joint C can rotate, joint D can rotate, and joint E can rotate. While sport A and B are fixed, those therefore these sports cannot rotate. But we can also take the advantage of the hinge sport or hinge beam to reduce the number of the degrees of freedom, and we can apply the modified Slope-Deflection equation on the member D to E to reduce the our number of the degrees of the freedom, like we did in the example of the beam structures, because we know that there is no moments at the pin spot in the pin spots, whether is the pin spot is in the beams or in the frame structures. Moreover, frame is like a combination of the beams or the number of the beams. When they are joined together, they form the frame structures. Now, if we when we apply this, use this joint E modified slope deflection in the span C to E, we are left with only two unknown limitations. One is at point C, which is theta C, and other is at point D, which is theta D. As there is no deflection, no rotation, so that is prevented in both in the vertical directions by sports A to B and in horizontal direction by sport E. So there will be no value of delta C or delta D. Or invert indirectly, I would say there will be no value of psi that we use in the case of the beam structures. Once we know the number of the degrees of freedom, we directly shifted towards the calculations of the fixed end movements. And for fixed end movement, I have told you that we will follow the inside cover of the book of R.C. Hibbeler's structure analysis. And from there, we can calculate the fixed end movements directly with the help of the formulas or with the help of the tables by looking at the conditions of the loading. For the frame A to C, if we consider the member A to C or the frame part A to C, we see that there is only a point load acting at the center of the beam. And for such types of beam, the formula for fixed end moment is PL by 8. The PL is the point load, L is the length of the frame, which is 20 feet, and 8 is of the formula, and it comes out to be 100 k feet. As it is anti-clockwise direction, so it will be positive energy. Similarly, if we calculate the fixed end moment at other end of the member, that is fixed end moment for CA, it will come out to be minus 100. While for the frame B to D and D to B, there will be value of 0, because we are going to apply the modified slope deflection equation in the member C to D. Similarly, if we calculate the fixed end moment, or the value of fixed end moment for B to D or D to B is also at 0, because there is no loading acting in the members B to D. Neither there is a point load nor there is a uniformly distributed load or varying distributed load. So when we have a 0 value of the moment, automatically it will going to be comes out to be value, it comes out to be 0. For the fixed time moment C to D and D to E, for the fixed time moment C to D and D to E, as because the loading is same, that is 2 kip per feet, so its formula can be used, the same formula will be used, and it will become for UDL, its value is WL square by 12, and the W is the UDL, which is 2 kip feet, and L is the span length, which is 30 feet. Don't forget to use this one span length. Do not add up these two span length. That you should use the 30 feet and not the 60 feet. And divided by 12 it comes out to be 150 kip fit in the positive directions, and similarly for fixed end moment D to C or fixed end moment E to D comes out to be minus 150 kip fit. Once you have calculated the slope and deflection equations, you can use the we can apply the slope and deflection equation. But before applying slope and deflection equations, there is a term which is used as E and I. You have two choices. One is you can use the directly input the values of E here, which is 29,000 KSI, and the value of I is given for each member. One member is given as 800, for other member it is given as 1600, and plug in that values and simplify that equations. And other method is that you can take the value of E as it is and the value of I as it is, and it automatically cancel out in the last step. But as we see that the value of inertia is different for both horizontal members and for the vertical members, so you can develop indirectly a relationship between them, because for value one is given as 800 to second is given as 1600. So for vertical or for horizontal members it can be calculated as 2I, it can be used as 2I. And we have to use this simple basic slope and deflection equation, which is m and f is 2 ei over l into 2 theta of n plus theta of f minus 3 of psi plus fixed end moment n into f, where n is the near support and f is the far support or far end of the member, which is the equation for the simple slope and deflection equation, which will be applied on the members A to C, B to D, and C to D, which are basically vertical members. That is member A to C, member B to D, and member C to D, where we do not have any pin support at the end or is a hinge support. While for the member D to E, we have a pin support or a hinge, and we will use the modified slope deflection equations, and which is MRH is equal to 3 I over L theta R plus minus I plus fixed end moment RH minus half of the fixed end moment HR. And the moment of HR on the other end will become equal to 0 due to nature of the sport, where R is the roller sport or rotation, and RH is the hinge end of the frame. Once we apply these values for the member A to C, it will become as 2EI over L, which is 30 feet into theta C. Because at the point A, we will have a fixed spot and its value will be 0. So value of 2 theta A will be equal to 0. And there is no deflection in the entire frame of the structure, so the value of psi will be again 0. And the fixed end moment will be added up in the equation. And it will be terms, so we simplify it and call it as equation 1. Similarly, we will solve the equation MCA and MBD, MDB, and to calculate the from the simplified equation in terms of EI and theta, so in terms of rotations. For member C to D, we find out that for member C to D, the value of inertia it comes out to be 2I that we have calculated. So we will use the value of 2I as it is, so that our equation will become solved easily in terms of I. Second, I have told you that you can put in the plug-in values of E and I, and you can directly have the value of like 1600 theta D, 1700 theta D, and something like that. While for the member D to E, we'll apply the modified deflection equations and its formulas. After solving it, it will comes out to be 0.2 EI theta D plus 225. And for other member end of the member, it will be equal to 0. Once we have the slope and deflection equations, we will write the moment equilibrium equations at the both unknown degrees of the freedom. When we have a 2 degrees of freedom, one is at point C and other is at point D. At point C, we will have only two members, that is A to C and C to D. So it will become as moment CA MCA plus MCD will be equal to 0, because there is no rotation or deflection at point C. And similarly, once we see the point D, we will have three members are connected in it. One is member D to B, other is member D to C, and third one is the member D to E. So we will write as MDB plus MDC plus MDE will be equal to 0 because we are writing equation at the point D. And all the members that are originating from the point D will come up in while writing the or while formatting the equilibrium equation of the frame. So we will have three movements because three members are connected at point D and two members are connected at point C. So we will only have two movements at point C. And as we have calculated the values of these movements in the last step of the slope and deflection equation, so we will going to just plug in these values in here, and we will, after simplifying these equations, we will come up that EI theta C will becomes as minus 79.45 kip feet square, and EI theta D comes out to be minus 96.59 kip feet square. And you are seeing here that first value is this is the M's value of MCA, second value of MCD, and the next equation we will have the value of MDB, MDC, and there is no value of MDE, this part, because in the MDE we have a zero moment. Yeah. No, the value of the moment will not be zero, but it will be simplified in terms of the theta d because we will have a theta d here, and once you simplify it you will get to reach to these values. Once you have the values of ei theta c and ei theta d, we will plug in these values back into fixed end moments to get the value of the member and moments, and you will get the value of MAC as 92 kip fit, and similarly the other values of the moment will be calculated. The values with the negative moments indicate that our slope or the rotation of the member that we initiate is opposite to what we have assumed. Like member MCA, we get the value of the moment as minus 115.9 kip fit. It means that the member rotation will be in clockwise direction instead of anti-clockwise direction. Because initially assume in terms of slope, and in case of slope and deflection method, we assume that all anti-clockwise rotations are considered as positive. So if any formula or in any equation you get the value of the moment negative, it means there is a clockwise rotation or clockwise movement in that particular member. Once you have the values of these moments, you can simply apply the equilibrium check on both equations, which are basically the equilibrium equations. Plug in these values back into the equilibrium equation and find out whether if there is any calculation error or you have performed the equation or not. Once you have filled out the member equilibrium check is okay, then you will move towards the member and shears. And the member and shears are going to calculate with the same procedure and the same method that I have told you for the beam structure. So if you do not remember that how we have calculated this end shear, I would suggest you to go back to part very first part of the slope and deflection equation where we have analyzed a continuous beam structure, where I have discussed in details how you can calculate the end shears of the members. The only different in terms of axial frame apart from end shears that you will get is the axial forces, which are basically the reactions, vertical reactions for the members A to B, which is 27.65 that you will get, and the same movement will move to other end of member but in opposite direction, its value will be minus 27.65. And similarly when it will move towards the member C to D, this value will becomes as terms will be counted in terms of the shear for the member C to D, and the shear or the on the horizontal direction in the member CD will become as the axial force in the horizontal member, that is 21.25 will become as the axial force for the member C to D. And similarly, you can calculate all the major or the remaining values of end shear and axial members for the members as well. But don't forget that I have repeated number of these times that while analyzing the frame, assume that you are standing in the middle of the frame, and from there you are going to view the different frames, and vertically are the forces that you are going to encounter vertically on the while standing in the center will cause the bending moment and the shear in the structures, while all the forces that are acting perpendicular to the members will be causing the axial force in the member. Once you have the member shears, you can calculate the values of the support reactions as well. Once you have the values of support reactions and the and moments and all the supports, you can draw the shear force diagrams of the structures and the bending moment diagram of the structure as well. And similarly, when axial force diagram, you can also draw the axial force diagram as well. The only difference in the beam and structural diagram is that we have a extra axial diagram in case of frame structures apart from shear force diagram and bending moment diagrams. All the values of axial force diagrams are considered positive when they are drawn outward, and all the values that are negative they are drawn inward in the frame structure. Similarly, you can draw the you will draw the shear force diagram of the frame and the bending moment diagram of the frame. Do it on in odd time and compare whether you are going to get the same values of the shear force diagram and bending moment diagram at each joint and each point of the frame or not. If you are facing any difficulty in getting these values, just let me know. Okay, the next problem that I am going to solve today is the non-sway frames with the sports settlement. The frames in which we have a sports settlement as well. In such type of frames, I consider the same frames that we have considered in the last example, but there will be no loading acting on the structure just for our simplicity. And the point B, which is the sport B, that is a fixed sport, settles about 3 by 4 inches, which is 0.75 inches. By the slope and deflection method, we have to calculate its sport. Now, again, first of all, the degrees of the freedom, taking advantage of this hinge sport or the continuous sport, we are going to have only two rotations, that is theta C and theta D. The sport settlement at point D will cause the deflection in the member B to D. That if the sport settle there is a sport settlement of 3.4 inches in the downward direction, the member at joint D will also settle with the same values of 3 by 4 inch in the downward directions. And ultimately, it will cause the rotation in the members C to D and D to E. And we will term these values as psi CD and psi DE. The values of psi C and psi DE can be calculated with the relation of the basic equation of the psi, which is psi is equal to deflection divided by length of the member or the length of the particular span or length of the frame. And but applying before applying this relation, you should know that you should have these same units for deflection and for length of the member. If we apply it for the member C to D, we have a deflection rotation of 3 by 4 inches, and the length of the member is 30 feet. So it will be multiplied with a 12 to convert it into inches, and you will get the deflection as minus 0.00208. Similarly, for members C, D to E, you will get its value as positive 0.00208. 8, while the value of C to D is negative, while the value of D to E is positive. Because once you see the frame while at the point C, that is C to D, the point D is deflected downward. So it will cause downward deflection, that is in the negative axis, y axis. So it will be in the minus directions. While if you see or the side D to E, that is you are at the point, this point D, and the point E is at the upper level. So it will cause the positive deflection in the frames. That's why its value is positive. It all depends upon the reference point that you are looking at the other spot of the member or other end of the member. When we say the size CD, it means that we are at point C or at the joint C and we are looking towards the joint D. If it is in the downward direction, it will be in the there will be a minus sign. And if it will be the positive directions or in the upward direction, its value will be positive automatically. So in this case, the value of the reflection is the same, but the opposite signs. Then we will apply the same value of the slope and deflection equations, and you can apply this fixed end moments and slope and deflection equations, and you will get to know that you will only have the value of the psi values will be considered in this type of equations, as there is a no fixed end moment. So you only have the value of ei theta c or ei in terms of theta t, and because there is no loading acting on the structures for all members of the frame. And similarly, we will in the frame D to E will apply the modified slope deflection equation. Once you have these fixed end moments, you will calculate the apply the equilibrium equations, which will remain the same which we have used in the previous problems. That is, at the conjoint C, it will be MCE, MCA, and MCD is equal to 0. While at joint D, it will become as MDB plus MDC plus MD should be equal to 0. Once you put in the values in this equilibrium equation, the values of the fixed end moments, you will find out the value of ei theta c and ei theta d. You can easily calculate it in your own times. Once you have this value of ei theta c and ei theta c, you plug these values back into the fixed end moment equation to find out the member and moments, and you will find out that the member and moments values can be calculated easily with the same steps that I have told you in the previous examples. Once you calculate the fixed end moments, just to remain on the safer side, that you are going to draw the correct axial force diagram, you are going to calculate the correct reactions, and you are going to draw the correct shear force diagram and bending moment diagram to apply equilibrium check, I would suggest. But it is not mandatory, it is for own safety and for your own purpose that you are moving in the right direction. There is a no calculation mistake or there is a no formula mistake in the problems that you are solving. If you get these values equal to 0, it means your equilibrium check is satisfied and you are moving in the right directions. In the next step, we calculate out the moment shear force for moment member and shears and axial forces, which using the same procedure that I have told you for the non-sway frames without sports settlement. The only basic difference between sports settlement cases for non-sway frames is that you will have to consider the value of the psi if you have a sports settlement, and you have to calculate its value very carefully, the value of the psi that you use is the constant dimensional constant units and the correct values of the convention sign convention, whether it's the positive or in the negative directions. And once you calculated the axial forces and member and shears, you can calculate the sports reactions, because ultimately the sports reaction is going to be the same, which is the member and shear at the sports. While at the joint C to D, you will see that it is going out to be the cancel out, that we get its values in the opposite direction. So there will be no value of member and shear or the support section at the C. Like at point C, you will see that there is a value of 4.11. One is going in the positive direction, other is going in the negative directions. So it will go ultimately going out to cancel out each other, and ultimately its value will becomes to be zero. But for the point E, you will get its value as 4.8 kips. All units are mentioned here as are in the kips for the reactions. Once you calculate the reactions, even if it's demanded that you have to draw the shear force and axial force diagrams and bending moment diagram, you can draw easily using the provided data, because the entire frame is converted from indeterminate structures to a determinate structures, where we have the each and every value of the reaction and each value of the moment. And using these value of the reactions and the moments, we can easily draw the axial force diagrams and shear force diagram and the bending moment diagrams of the frame structure. That's all for today. But at the end, I would like you to suggest you that you should also carry out the practice of the slope and deflection problems and examples solved in the book of R.C. Hibbler's and the book of the structural analysis by Alexander Charges. By using these, adopting the or by using the same methodology that I have taught you in the class lectures. Once the more you practice, the better you will overcome, or you better will understand the slope and deflection method. As they said that practice makes the man perfect. But during times of practice or in terms of revising this lecture, if you encounter any difficulty or there's any point that you did not understood, or might have skipped that point, you can ask me either in the comment section or through email. I will respond you as soon as possible. With this, I would like to end our today's lecture. In the next lecture, I will going to cover the sway frames, and in the next lecture, I will cover the inclined frames, so that all types of the frame will be covered in the course. So at the end, I would say thank you to you, and thank you for listening this or listening this particular talk. Thank you. Allah Hafiz.